Now we will discuss about few terminologies, very important terminologies. So what is state? The state means the positions, right? The positions of any system. What is state space? It is defined as the set of all possible states that a system can occupy. So state space can be discrete or continuous. Then next one is parameter space or time sets. So for any stochastic process, it varies in time or space, which is called parameter of the process. So the parameter space is the time sets or set space. Also, the parameter space can be discrete or continuous. So if we consider the values or states of a stochastic process constitute the index parameter, which is denoted by small t here, then all set of possible values of this index parameter is called parameter space, and it is denoted by capital T. So we can say the values for capital T is 0, 1, 2, 3, and so on. Or in other way, we can write T, it lies between 0 to infinity. Now more on about stochastic state spaces and time sets. So as we discussed earlier, state space can be discrete and continuous. Also, the time sets are discrete as well as continuous. So the state of a model is the set of variables that describe the system at a particular point in time, taking into account the goals of the studies. So we can say the state of the model, it depends on the goals of the study. It is also possible to represent any future scenarios as states. So now if we consider discrete states, they are the variables exhibit step function changes in time. So if we consider for a person living status, that is a state of alive to death. So see, here we have the state's outcomes as discrete. Either he will be alive or he will be dead. On the other hand, for continuous states, the variables change continuously with respect to time. So again, if we consider a real life example, say the values of investments. So investment values, it changes continuously. Also, we consider the real-time changes as continuous. Now, the definition of stochastic process, or what is stochastic process? So mathematically, we can define stochastic process as like here. So what is stochastic process? Stochastic process is a model for a time-dependent random phenomenon. So just as a single random variable, it describes the static random phenomenon, and the stochastic process, it is the collection of random variables xt, one for each time t in some set j. That means here we consider the state space as xt, the outcomes, and where each time t, it is a subset of j. So mathematically we can define stochastic process as xt, where t belongs to j. So the set of values that the random variables xt are capable of taking is called the state space of the process, which is also denoted by capital S, the state space. Now again, if we consider a real life example to make you understand about what is stochastic process. So see here, if we consider a business office, it has 5 telephone lines, and any number of these lines may be in use at any time. So the telephone lines are observed at regular interval of 2 minutes. So here X is number of lines in use in every 2 minutes. So we can say the values for our capital T is 0, 1, 2, 3, and so on. And what about the values for xt? It can be 3, 2, 5, 0, 1, 0, 3, because we have in total 5 telephone lines. So the value for xt, it starts from 0 and not more than 5, right? So the value for xt must be between 0 to 5, and it is discrete value. So we can use 0, 1, 2, 3, 4, and 5. So how we define the stochastic process for this example? So we know stochastic process xt, where t belongs to capital T. Here the parameter space capital T, right? So capital T is 0, 1, 2, 3, and so on. And the state space is x, where the values are 0, 1, 2, 3, 4, 5. So if we see it on the graphical presentation, so see here, we start from 9, so it is 9 a.m. and number of busy lines. Here see, only one line is busy, and after 2 minutes still one line is busy. After 2 minutes there are 4 lines whose are busy. Again after 2 minutes 5 lines are busy. That means all lines are busy. However, after 2 minutes, see here, all lines are free. And again, after 2 minutes, all lines are free. So see, in this way, we can have the state space of this experiment considering this time sets. See, after 2 minutes time interval. So this is our stochastic process. Now the classification of stochastic process. So we can classify stochastic process according to the nature of the state space as well as the time sets or parameter space. So as we have already known that state space are two types, it can be discrete or continuous. Also the parameter space can be discrete or continuous. So if we consider this cross tabulation, then it will be very easy for us to understand the classification of different types of stochastic process. So when the state space is discrete as well as the time sets is also discrete, then this stochastic process is called discrete state space with discrete time changes. Similarly, this is called the stochastic process with continuous state space with discrete time changes. So the state space is continuous, however, the time changes is discrete. Likewise, here discrete state space with continuous time changes stochastic process. So the state space is discrete, however, the time set is continuous. And finally, here both are continuous. The state space is continuous. Also, the time changes is continuous. So it is defined as the stochastic process with continuous state space with continuous time changes. So these are the 4 types of stochastic process considering their state space and their parameter space. So I hope now you can understand the classification of stochastic process. So that's all for today. Thank you.